place is so well prepared, I don't have to do a check, you know. That's the main reason I wanted to do public speaking, because it sounds so cool. All right. Yes, I'm Shohre Mansouri, as Kate introduced me, and today with Effy Elden, we're going to talk to you about how we can improve doing infrastructure as code. But I'm going to start with a story, as we all like stories. And this is my story, which is even better. And I am a business, web-based business application developer for 18 years. I really believe in doing test-driven development. I'm a TDD enthusiast. Naturally, I like to have a good test coverage for my code, and I love refactoring. So before there was infrastructure as code, before anyone in the industry knew what IAC was, this is pretty much how my day looked like. It was me and my laptop, well, when I wasn't in the meetings anyway, and also there's usually another person sitting next to me, when I'm doing, most of the time we're doing pair programming, but to make my story more dramatic, I'm just going to ignore that person. Yeah. So this is pretty much how my day looks like, or looked like. Me and my laptop. Well, me typing away on my laptop. Everything that I needed was on my laptop. I had a web server, a database. Everything was so close to me. Everything was so fast. And I was just basically typing away, creating quality code, or that's what I think, and it was just great. To give you a feeling of how my workflow looked like when I was coding, I'm going to show you a video of one of my favorite tools, which is helping me doing live testing. It's called nCrunch, and it helps you doing red-green refactoring for Visual Studio languages, like C# in this case. So as this video shows, I would always start with a breaking test. nCrunch shows me really clearly where my test is failing. Like you see that red cross is showing where my test is failing, and it shows me why my test is failing. Then I can go about to the actual code and try to write the business application code. Now you watch this code. It will eventually go green, very clearly showing that my code has some tests covering those lines. And it also shows me where I do not have a test covering my code, which is with that black dot. So it's just perfect. Everything is fast, very, very fast feedback cycle. And it feels like I'm in this bubble, in this perfect world, away from everything else, and I can just keep working and creating the main thing that I'm there to create. I mean, eventually I may have to go out there and do stuff with the scary servers, you know, building some firewalls here and there, setting up some configurations, but I would just go back to my bubble again and keep coding. So it was all great. Even when we started moving our servers to the cloud, things didn't change much. It was still me in my bubble, sometimes going out, doing stuff on the servers in the cloud, and going back to the bubble. Until things changed, you know, as they do. And we started doing infrastructure as coding. We, as an industry, started to write code for the scariest stuff out there. And it was good, all well and good. I also joined the team that they were doing infrastructure as code. And initially, I was very excited. You know, like there was lots of new tools doing cool stuff, and I was learning a lot of things, and I was enjoying it. But after the excitement was gone, I started that things weren't quite right. I wasn't comfortable with the things that I was observing. For one, everything was so slow. I mean, for the engineers that they were having a really good fast feedback cycle when they were doing the business application coding, it was somehow acceptable to do some change on the infrastructure as code, check it in, and they wait for 5, 10, 15 minutes to find out, oops, they had some mistake somewhere. Do the fix and wait for another 15 minutes. It was really slow and frustrating for me. And there was long bash files, long, unreadable, not easily maintainable bash files that I was really scared to touch. And there was no test. There was lines and lines of infrastructure as code that it had no test. So I wasn't really confident that if I did some change on my code and if I had done some mistake, I wouldn't know if I'd broken anything or not. To be fair, there were some tests that they may break if I had done something wrong with the infrastructure as code, because they were the business application side of things, they were tested and they were obviously relying on the infrastructure to be there, and they may break. But first of all, it was really hard to find out. You had to just dig down in all the logs everywhere to find out, yes, that was the thing that I did wrong with my infrastructure as code. But they weren't explicitly testing my infrastructure as code, and it was hard to find out. So it was as if my bubble was burst. I basically had lost my perfect world, and I was sitting next to this scary stuff out there. I was just sitting next to the firewalls and everything, which wasn't fun. So I tried to make sense of the situation and just list the things that were not quite right. Obviously, I had lower productivity because of all the long waiting times that was there. The code was lower quality, as I explained. They weren't readable, like long bash files, scary to touch. And I was less confident to do any change because there was no test. Like, I don't dare to change a code that has no test. And as I said, I love refactoring, and when there is no test for a code, I would never touch it if it's working. If it's working, just leave it there. Don't touch it because there's no test. And last but not least, there was less fun. I couldn't concentrate as before, and I wasn't really proud of the long bash files that I was working on. It was just not a beautiful product that I could say, yes, I produced this. So that made me really sad. And I wasn't sure that if this is the case, is it just something that I just need to suck up and learn, and this is my life from now on because of infrastructure as code, or if this is something that we can change. And that's when I started thinking about working with Effy. Effy is a lot better than me in doing infrastructure as coding, and I thought together maybe we can make sense of this. Maybe at least we can understand, yes, this is how things are, or maybe we can change it together.
When Shohre came to me, it was really interesting to me, and these were a lot of topics I hadn't thought about. You see, I come from a very different background to Shohre, one almost the opposite. I started off in the world of systems administration, support, network administration. I was living among the scary servers from the get-go. I never had a bubble I could rely on. If I wanted to make a change, I just had to make it after hours and hope nothing broke. And so I started thinking about the questions Shohre had put to me and if we could really do better. And what I realized was it wasn't just about infrastructure, because we've gone from having application code, just the code for our business applications in our repositories, nice and fine. But suddenly there's so much more. There's infrastructure, pipelines, configuration, deployment, provisioning. And by next week, there'll be another type of as code in your repositories as well. We're doing all the things as code. But I realized that as we'd started to expand code and our usage of code, we hadn't kept up those same disciplines and rigors and tooling and all the other practices that meant that we were really confident in our application code, and we hadn't applied those to our as codes. And so when I started working with Shohre, the question we had was, can we do better? And we pinned it down based on the complaints Shohre had into two areas. The first was, could we have a faster feedback cycle? Could we reduce some of those slow delays and reduce developer frustration, increase productivity, and just have a better time when working with infrastructure as code and as code in general? The second was, could we produce higher quality code? Could we write code that when we pushed it, we were sure would work correctly and would stay working? And my first instinct when we posed these questions was, what is the lowest hanging fruit? And so these are the four categories that we've sort of broken down our findings into. And the first one I'm going to talk to you about today is local validation. So, low-hanging fruit. What were the things that I thought we could easily improve or fix that didn't require a lot of work, that didn't take a lot of time, that weren't that revolutionary, but that somehow seemed to be fairly missing from a lot of code bases and a lot of engineering teams? The first, most basic thing, syntax check everything. We're very used to running linters and syntax checkers for all our application code to make sure our JavaScript doesn't miss a semicolon or our PHP isn't missing a bracket. But when it comes to our as codes, our pipelines as codes, our infrastructure as code, often we just don't have that kind of automatic syntax checking, either locally or in our pipeline. And that can lead to some really basic mistakes. And pipelines as code is a great example of this. When I started looking at this and looking at pipelines as code and some of the problems we face, what I realized was pipelines are code that don't run until we push it by default, because it's code designed to be run in the pipeline by the CI tool, not locally. And that felt wrong to me. In what other area would we accept code that we couldn't run, we couldn't know worked until we pushed it and hoped? So as an example, this is a very simple change to a pipeline as code with Circle CI. I've tried to add in another job to make it so that it builds a binary for Mac as well as Linux. I wrote this in, it looked fine. I pushed this to GitHub, as you can see, it all looked good. So everything was fine, right? Unfortunately, nope. I broke the build. Hell, I didn't just break the build, I broke all the builds. I broke the entire pipeline. Nothing was running for anyone because the entire pipeline was now broken. Why? The YAML. I was a YAML and I had forgotten a single colon. I had made a change that looked straightforward, I'd pushed it, and I'd broken everything. So what could I have done better in this situation? How could I have avoided that? Well, the obvious answer, as I mentioned earlier, would be, I can syntax check my pipeline. It could be YAML, it could be Groovy, it could be JSON. No matter what, it's a language. Languages have rules, and there's plenty of tools out there, like YAMLint, which can make sure that at least what I'm pushing is not completely broken. But as I did more research, there is better and more advanced ways we can make sure our pipeline as code will work. And one of those is validation. Many CI providers and platforms have tools that will validate the pipeline. And that means you're not just checking, does this make syntactic sense? Is it readable? It's, does this tool understand what I want it to do? If I give it this pipeline, will it actually know what I'm telling it to do? And so that's a really great step you can take with nearly any CI tool. Having that as something you run locally before you push a change to your pipeline means you at least don't break everything for everyone. But there is a gold standard I discovered, and there are few CI providers and platforms out there that offer it, and that's running your pipeline locally. So with the right tools or the right CI provider, you can actually say, this pipeline job that I've defined, run that on my computer as if I was the CI platform. And that way, you have the ultimate confidence. It's not just that it works, it's that it does what you want it to do. And I believe that's the golden standard, and that's what we should be aiming for when we are working with pipelines as code. And so here are some examples of CI tools and providers that do offer that kind of running your pipeline locally and making sure that things will work. Don't worry about taking these names down now, as we'll have a website shown up at the end where you've got some more examples of those. Now, after pipelines, I realized another area where too often we've approached that mentality of make a change, push it, and hope it works is, of course, infrastructure. Infrastructure as code, it's tricky. And when I looked into what the easy wins were, I found some things that were very beneficial to us. But I also found a lot of frustration, and you'll see a bit why. So this is a very, very simple piece of Terraform code. It's designed to create an AWS EC2 instance in the cloud. It's a small instance, it's running Ubuntu, it's got a tag, it's got a name. But I've written this code and I want to make sure it works before I push it, obviously. So what can I do? Well, the first thing I do is I run Terraform format. That's a built-in command, and it formats my code and it goes, yes, you haven't missed some indentation, you haven't done anything terribly wrong with your syntax. This is a valid file. Next I run Terraform validate and it actually goes, okay, this file makes sense to me. I know what you're trying to get me to do. And as a final step, I run Terraform plan. And when I run Terraform plan, Terraform actually goes into my AWS account with the credentials I've given it, looks at what's there. It looks at the code in my repo and says, here are the differences. Here is a plan of exactly what I'm going to do if you run me. That all passes, so I'm like, yeah, cool, my code works, and I run it. And it fails. And do you know why it failed? It failed because I had given an invalid type of instance. T2.verytiny is not a real instance type. It doesn't exist anywhere in Amazon. So this code could never have worked. But Terraform was happy to validate it and even plan doing something that could never have worked. And I find this baffling and really quite disappointing. You see, if I go into Google Maps and I say, plan me a drive from Melbourne to Auckland, I don't expect to know how long that hypothetical drive will take. I expect it to fail because that is an impossible plan. And really, I expected Terraform to fail when I told it to do something that was clearly impossible. And so a takeaway I really want you to take away from this is we should be demanding better. We should be asking more of our infrastructure tools, of our infrastructure platforms, to give us that confidence and to not lead us in these circles where we can't possibly know if something's going to work until we try to actually do it. That said, after I was over my frustration and what had happened, I looked at, again, what could I have done better? What were the options available to me? And the one I came up with was extra validation. So I'd run Terraform format, Terraform validate, Terraform plan, and those had all passed. But it turns out there's third-party tools out there being developed that help you validate things in other ways, that help you do checks for common gotchas or common things that never would have worked, including an invalid instance type. And this is an example of a couple of tools that do that for Terraform and CloudFormation respectively. If I had run tflint on my code before applying, it would have pointed out to me very easily that, hey, that's an invalid instance type. This code won't work. And so that is one way that you can have a bit more confidence in the infrastructure of code you've written and why and if it will work. However, everything I'm telling you is great in principle, but there is a bit of a catch. And that is, it can be hard to do the right thing. It can be hard to syntax check everything if you have, a YAML pipeline, some Terraform code, your application code in Kotlin, maybe a bash script. It'd be hard to run those 4 different syntax checking tools, or run your pipeline locally, or run your application tests. And it can be hard to wait if you just want to run everything to make sure, say with a pre-check-in script that runs all the different tests and lints. That's a long wait, and it can be really frustrating and easy to want to skip. So one question that came out of this at the end of my little delve into those local validation bits was, how can we make it easier to do the right thing? How can we make it easier for developers to do the best thing with the best practices we can? And the answer I came up with, which I think works pretty well, is it's pre-commit hooks on your source control. So a pre-commit hook is something that you register in your source control repository, and whenever you go to make a commit, to make a change of code locally, it runs a set of scripts or tools, and those can fail the commit if the commit is busted in some way. Unfortunately, I'd used pre-commit hooks before in teams in the past, and there was a bit of a cycle I'd seen them get into. It looked a bit like this. So we have a pre-commit hook, and it needs to do everything. It needs to do all the things, as I mentioned. But that means it becomes slow. it becomes overloaded by trying to do too much. Developers become frustrated by this. I just changed the light of the README file. Why is it running on my unit tests? And as a result, eventually, developers bypass the hooks. They go, this is clearly fine, I'm just going to skip the hooks, push the code. And sooner or later, that leads to bad code being pushed, breaking the pipeline. At which point, you may as well be like, well, why did we have hooks at all? Let's get rid of them. So what makes a good pre-commit hook? How can we use pre-commit hooks in a way that don't lead to that cycle? And there's 4 different aspects to that that I feel are very important. The first is a good pre-commit hook. It should be selective. What that means is when it runs, so when you're making a commit, it should only run the things it needs to run based on what you're changing. If, as I mentioned, I am just changing a README file, I should not need to run my unit tests. If I'm just changing my pipeline, I want to run a pipeline validation and maybe run it locally, but I certainly don't want to be running my infrastructure checks. Secondly, it should be fast. You should never put anything in a pre-commit hook where if that running is going to slow things down enough that you get frustrated, then you shouldn't be putting it in there essentially. So don't go putting in integration level tests that take 10 minutes for your code to run, because developers are going to get frustrated and bypass, and that's fundamentally not what you want. Obviously, they need to be consistent. That means they need to run the same way on your machine, on another dev's machine, and in the pipeline. And containerization tools like Docker can be really helpful here to make sure everyone's aligned on the same versions and with a similar environment. And lastly, they need to be helpful. They need to fix something that they are capable of fixing. If I have missed a space and my indentation is slightly off in this file, I don't want my entire commit to fail. I just want it to fix that as I'm committing and let me know that that was changed. And if there is a problem it can't fix, like a syntax error, I need clear feedback about where that problem was so I can address it quickly, get my commit through, and be happy. Here are some examples of what I've deemed smart hook helpers. These are tools that let you set up and manage pre-commit hooks in a way that can be smarter, faster, and better, and not lead to those frustrations and that cycle. As we started to look more into our as code, especially our infrastructure as code and Terraform code, me and Shohre realized that a lot of the really good practices that we are used to as software developers did still apply to our as code, as long as we thought about it the right way. And these are practices that Shohre had been using for many, many years. So she's going to talk to you now about how we can apply those to our as code.
So even though infrastructure as code is relatively new and maybe somewhat immature in our industry, but coding is not new. We've been coding for a long time now, and there are a lot of good practices that we have realized and are following these days when we are coding or application coding. And we just need to have the mindset that infrastructure as code is still code and still has to follow those good practices, the ones that they make sense anyway. So we started looking at one of the main things that we know about good coding, and it's clean code. Many of the concepts about clean coding do apply to infrastructure as coding or any type of as coding anyway. For example, dry principle, do not repeat yourself. If you need to change one thing for your code and you end up going to 2 different places to change the same thing, that's usually an indication that you need to pull that piece of code into one shareable piece. In Terraform usually is translated to modules, so that you don't have to repeat yourself. The code that we write needs to be readable. We are authors. Every time we write anything, any code, someone else is going to come back to read what we have written, including ourselves. So that means our code should be readable. It should be intention revealing. The names of the files, variables, function, whatever we have, it should make it easy for the person who is reading our code to understand what we were trying to do. And if that means that our files are smaller because that makes navigation through the code easier, we should definitely do so. There are also other good practices that we can follow apart from clean coding. For example, we obviously need to use source control. We obviously need to keep the history of how we change our infrastructure as code and keep it in a source control. One thing that we may or we should not have in our source control is the state of our infrastructure. When it's a one-person team, maybe it's okay. Maybe you can get away with having your state in the repository. But once there's more people in the team, definitely we should have our state of infrastructure somewhere away from the repository so that it's not possible that it gets diverged in two different directions that's basically not manageable. All the environments should be as close as possible. We don't want surprises. So that means all the developers' environments and all the test, production, staging, all of them should be as close as possible with the same versionings of the tools. And if that means that you should use containers, yes, definitely that's an option. And we need to pick the right tool and language. There are not a lot of different tools and languages as yet, but there are still options that we need to do a bit of study, a bit of research to find out what's the best tool that is going to work for our scenario. And we also need to respect the idea of the designers and the makers of those, the people who have built that tools. So one of the mistakes that we usually make is we pick a declarative language like YAML, and then we try to bash it, no pun intended here, we try to bash it to become an imperative language. And that's not good. If we are going to expect some behavior from a declarative language, that means usually it's the time that we need to introduce another language into our tech stack. And we need to write tests for everything. If there is no test for your code is broken. So we need to make sure we write tests for everything. Obviously, unit tests and integration tests, that's what we looked into, and Effy is going to explain about how we got to do some unit testing.
So we started looking at testing, especially testing of infrastructure as code specifically. And as developers, we're all quite familiar with the testing pyramid. But one thing we thought it was worth noting, as Shohre mentioned at the beginning of the talk, was that as well as our traditional unit integration and end-to-end tests for the infra, we do have these kind of overarching functional tests. That is, tests of our application which implicitly rely on the underlying infrastructure. If your web server is not running, then your web application tests aren't going to pass. But you can't rely on those because it's very difficult to know what the problem is, to debug that problem, and also to prevent the problem from escalating, because it's not very consistent when those occur. So we started looking at how can we do tests for infrastructure as code, and we started with unit tests. And so the question we had when we were looking at this was, what defines a unit test? Because we are very used to tests in the concept of application code, but obviously infrastructure is a bit different. And we looked to Martin Fowler for some guidance, and these are some quotes from Martin Fowler that we thought were useful. The first was, a unit test should be a low-level test, focusing on a small part of the software system. The second was that a unit test should be significantly faster than other types of tests. It should be something you can run easily and quickly. And with those definitions, what we realized was unit testing infrastructure as code, it's kind of like unit testing SQL queries. That is to say, it's hard to do. It doesn't add much value, and it doesn't really give you confidence. And that's because for an SQL query, an SQL query might pass, it might fail, it might give you the wrong results. And all of that depends on the database that you're running it on, which is a separate system. So taking an SQL query away from the database and trying to test it in isolation gives almost no value. And we found that was the same with infrastructure as code. Taking a piece of infrastructure as code, separate from the cloud it's designed to be applied to, you can't really get that kind of testing and quality. And when we looked at what had been deemed unit tests, in the world of infrastructure testing out there, I realized they fell into 3 different categories. The first was mocking your cloud provider. So that is, you can take your infrastructure code, your infrastructure tool like Terraform, and you can run something that approximates an API used by, say, Amazon, and run it against that. Unfortunately, while that was good in theory, we found it didn't add much value. For starters, half the Amazon services we were testing either didn't have a mock API, or the mock API implemented wasn't compatible with the very detailed contracts that Terraform was expecting, and so a Terraform apply would fail for completely unrelated reasons. Secondly, in the cases we did manage to get a test to run against a mock version of Amazon, we realized that still didn't actually give us confidence it would run against the real Amazon. And so if you're interested in pursuing this, and I think it is worth looking into, because the types of infrastructure you're working with and the context you're working with is so dependent to what's going to work. Here are a couple of examples of cloud provider mocks. The second type we saw was what we've deemed convention tests. That is, tests that just look at the code you've written and say, does it match certain criteria? E.g., are all my databases with encrypted true? And we think these definitely have a place. They're great for compliance, for making sure that something matches security, or they're great for enforcing conventions, e.g. all instances should be in AP Southeast 2 in Sydney. But again, they're not really testing, and they're not really giving us confidence that the code we've written has worked. The third and most common type we saw was, these are a couple of examples of those convention tests, and they do have their place. But again, we didn't find them to add value in terms of, will our code actually work and do what we want? And the third option we found was unit testing against actual cloud providers. That's where you take, say, a Terraform module, and you run it against a real Amazon account, and then you look at, did that apply successfully and what's in the account? And this worked well. It actually gave us confidence that what we were writing would work and would do what we wanted. The problem we found was we really couldn't classify this as a unit test by the definitions we'd given. And so we started to look into integration testing, as that's where we felt the real value lied. And Shohre is going to talk to you a bit now about how the integration testing worked for us.
Am I going back? Sorry. So integration tests. Let's also get to a definition from what integration tests are, again from Martin Fowler. So Martin Fowler defines integration tests as testing whether many separately developed modules work together as expected. But as Effy said, we couldn't really do a unit test for our modules, because module is the smallest block of tests for infrastructure. So I'm just going to go about now and write one test on one module, which is going to talk to the actual real cloud provider, and then we get it from there. So let's say I'm going to create an S3 bucket. So I'm going to write a test that if my code for S3 bucket creation is worked, I'm going to see what I'm expecting that has happened. So obviously I'm going to expect to have an S3 bucket, so it should exist. There should be an ACL public read, and I should have a policy that all of the objects in my S3 bucket have read access. Then I can go about and use whatever pattern or whatever copy or paste that I usually do from Terraform website. And then create the actual code for creation of the S3 bucket. So the resource, the bucket name, the ACL, and the policy. So firstly, this is an integration test. Even though we are just testing one block of tests, but if the test fails, there are many different things that could be the reason, not only my actual code. It could be that the actual IAC tool has changed. It could be that the infrastructure out there that I'm relying on has changed, like a VPC or something that I'm expecting it to be there. Or it could be that the cloud provider's API has changed. AWS has changed something. Or their offering has changed. So our test is actually making sure that these things work together. this is working, making sure that the integration of all of these things still work together. So we call this an integration test, even though we are only testing one module, one block of our code. And some people may not agree that this test is valuable because it looks exactly similar to our implementation. But Effy and I think that it does add some value. You need to see for yourself, for your scenario, if this is something that works for you or not. But what we think is valuable is it shows us that our code works and it keeps working, because it makes sure that all of those things that can go wrong, they still are working together and the integration still works. And even though I said there are disagreements for testing in that level, there is definitely agreement in testing the higher level and testing to make sure your different modules, they work together when you put them integrated. Basically, you need to integration test all of the different modules that you have in your project. These are some tools that you could use for doing integration testing of your infrastructure as code. We, as Effy said, have a website which is called dobetterascode.com. There we do have a repository of some sample tests and like a sample project with testing and everything that you can have a look at, and also a list of all the different toolings that you can use when you want to do IAC. That's our findings for today. So let's do a bit of a summary. The question that we started was can we do better? The answer is yes. Well, to be honest, sort of. And so the questions were like, can we have a faster feedback cycle? We definitely can have a feedback cycle. As Effy explained, we need to syntax check everything. We need to run our pipeline locally. We need to do extra as code validation and try smart pre-commit hooks, as well as making sure we pick the right tools and languages. And we wanted to have a higher quality code. Obviously, we need to follow the principles that we already know, like dry principle, don't repeat yourself. We need to make sure we produce readable and maintainable code, and we need to make sure we write tests in different levels. Anything else is we still need better tooling. We still need to either contribute to the open sources out there or demand from cloud providers to give us better tooling for us doing our work in a better way. And as individuals, we also need to appreciate that we have a role in this, and we need to continuously improve the way that we do infrastructure as coding. Thank you very much.